Hi, how are you doing? Welcome to our last video on applications of differentiation. After this video, we'll start discussing partial differentiation, which is also part of calculus 1. If you have not watched my previous video, check them on the link shown here or in my video description here. We have already covered several methods of differentiation and application of differentiation that are common to KNEC exams. Now I want us to discuss a question on a concept we introduced in the last video, that is one of the application of differentiation, differentiation of inverse trigonometric and inverse hyperbolic functions. So we are going to do a next question on that. This is October-November 2017, and it is diploma in electrical. This is the question 3B. We are told given y is equal to exponential tan inverse x, show that 1 plus x squared into second order derivative of x of y with respect to x plus 2x minus 1 dy dx is equal to 0. That question is 8 marks. 8 marks. Now, how do we go about this? So let us get the task. We are told y is equal to exponential tan inverse x. So here it is up to you to notice or identify the method of differentiation you should use. If you look at this one, it looks something that we should be chain rule. Remember how I was showing you this forms the inner function and the entire of the exponential forms the outer function. That is a composite function and we should use chain rule. That was my very first video. So if you have not watched that video, check that video in the link shown here or in my video description here. It will be the very first video in differentiation. Now, here if we say that u to be tan inverse x, we call this the inner function, then y will be exponential u. The derivative of x or y with respect to x will be derivative of y with respect to u, derivative of the outer function, times the derivative of the inner function, which is derivative of u with respect to x. Here the main challenge will be how to obtain the derivative of u with respect to x. I think that will be but we have done it in the previous video. Let us start by getting du dx. Then dy du is much easier. Du dx, since u is equal to tan inverse x, from our previous video on differentiation of inverse trigonometric function, if we apply the cancellation equation on both sides, tan u is equal to tan inverse x, or simply tan cancels out tan inverse so that you have x, or simply x is equal to tan u, which now means if you differentiate with respect to x, derivative of x with respect to u is equal to, you differentiate tan function, you get sec squared u. But we wanted to get du dx, not dx du. So du dx is equal to 1 over dx du, or we simplify the reciprocal, which is equal to 1 over sec squared u, or simply du dx dx is equal to 1 over sec squared u. But we also know that sec squared u is equal to 1 plus tan squared u. So that now, but tan u itself is equal to what? Tan u is x, meaning tan squared u is equal to x squared, which now gives us I think here I can write from the top and move this line, which now gives us sec squared u is equal to 1 plus tan u squared. Tan u squared is x squared. It now gives us du dx is equal to 1 over sec, I forgot this one, sec squared u, 1 over sec squared u, which is equal to 1 over sec squared u is equal to 1 plus tan squared u, which is x squared. So that's how you get du dx. To get dy du, you want it differentiating this exponential function. When you differentiate the exponential, it remains exponential. So dy du will be equal to exponential u. Whose derivative of exponential u remains exponential u. But what is u? U is tan inverse x. So that now dy dx is equal to dy du times du dx. Dy dx is equal to dy du exponential tan inverse x times du dx, which is du dx, here du dx is 1 over x squared. No, 1 plus x squared. Which means now we're also supposed to get the second order derivative. Where? Here we are supposed to get second order derivative too. Now, the second order derivative of y with respect to x is equal to derivative with respect to x of the first order derivative. Derivative with respect to x of the first order derivative. And what is the first order derivative? This one. So it means, again, we should differentiate this. Put it here, differentiate it with respect to x. Things getting complicated. It may appear so, but I don't think it is as difficult. Let's see how we can go about that. Now, remember, when you are differentiating a ratio, use quotient rule. Let this become our u. No, we can't use u because you're already using u somewhere else. Let this become let's use letter W and V because we are already using V and W. So if you are differentiating with respect to x, tan inverse exponential tan inverse x all over 1 plus x squared is the same like we are differentiating with respect to x, w over v. What does quotient rule tells us? If we are differentiating w over v it will be take V the way it is, differentiate W minus, take W the way it is, differentiate V over V squared. We will need the equation, so we will not remove the equation, but we remove this. So if you want to pause the video so that you can see everything, and then like later in your book, it's now time to pause the video and get to see everything. I have limited space, but that's the way things are, so that's why I have to keep on lapping the board. Now, what is our W from that? W is exponential tan inverse x. If you differentiate W with respect to x, it is just repeating everything we have done up to that, up to which point? Up to this point. Because this is what we started with. Which one? This one. Only that initially we were calling it y. See, y is equal to this. W is equal to this. So it's exactly the same thing we are differentiating again. Do we really need to have to do all that work? No. Just give the result. Exponential tan inverse x all over 1 plus x squared. Simple. V is equal, the numerator, 1 plus x squared. Let me remove this solution. That doesn't appear like you are starting to solve again. dv dx is 2x. dv dx, we are differentiating with respect to x here. We want v prime means dv dx. I don't know whether this one has a problem if I write it like this, but I think if you have watched my previous video, you should not have a problem now. This is v, w prime is dw dx, which is what we are trying to find here, minus w, v prime is dv dx, is what I was trying to find there, all over v squared. Now our second order derivative of y with respect to x becomes v. What is v? 1 plus x squared dw dx exponential tan inverse x over 1 plus x squared minus w here, which is exponential tan inverse x times dv dx. What is dv dx? 2x. That's why I left that space. All over 1 plus x squared, which is a v, but a v squared. Cancel. This is exponential tan inverse x. This one we have cancelled that, minus 2x exponential tan inverse x all over 1 plus x squared. That is our second order derivative. We have our first order derivative. This one, our second order derivative, this one. Now what is remaining? Put them in the equation. Check whether that equation will become 0. If the equation becomes 0, then we are sure whatever we have done is the correct thing. I don't know whether we should remove this. I won't remove this because I need it. I no longer need this. I will remove it so that I have a space for putting that. Hope it won't confuse you, but problem is my board is not as big. So now we want to put this in that equation. this first order in that equation. So we have 1 plus x squared times second order derivative of y with respect to x, which is this one. Oh, by the way, you should have factored out that tan inverse, exponential tan inverse. It's okay, you can factor it out. Times exponential tan inverse x. What is inside the bracket? You factor this tan inverse and this. If you factor out this exponential tan inverse and this exponential tan inverse, you'll be left with 1 minus 2x. 1 minus 2x all over this 1 plus x squared. Of course, here one term will disappear with that, but we finish writing so that we can see what will disappear and what will not disappear. But it's no problem, we can simplify it. Then plus 2x minus 1 first order derivative. Where is it? This one. Tan inverse, exponential tan inverse x all over 1 plus x. The entire of this term disappears with one term here. So that finally we have exponential tan inverse x, this one, into 1 minus 2x all over 1 plus x squared. I've made this mistake here. I hope it won't confuse you. Someone might get confused by that mistake, so it's good we correct it. So now plus 2x minus 1. Here there is nothing we are changing, we are just writing it. Tan exponential tan inverse x all over 1 plus x squared. I want us to open this bracket. Open here. Exponential tan inverse x, I'm opening the bracket, all over 1 plus x squared. I'm also minus negative 2x tan. By then the denominator is the same, 1 plus x squared and 1 plus x squared. So you can just say the denominator is the same. See, it's the same. 1 plus x squared, 1 plus x squared. They are sharing the denominator. So you can put everything over. So when you open this bracket, negative 2 exponential, this I'm opening this and this, tan inverse x, here I'm opening this and this, plus e and this and this, 2x exponential tan inverse x. Then because I've already multiplied this and this, I'll now multiply this and this, minus exponential tan inverse x. We are now done. Can I reduce to 0? I think it will. Because this will cancel out with this. So that value will cancel out with this value. This positive 2x exponential negative tan inverse x will cancel out with, this negative value will cancel out with this positive value. So finally you have 0 over 1 plus x squared. Any number divided by 0, it is 0. So it has balanced, meaning we have our 8 marks. But we see how much involving it was. It requires thorough knowledge of differentiation. I like differentiation because even in other topic in engineering, whether mechanical, electrical, civil, differentiation will always keep on appearing. Although I don't think we should do as much differentiation as electrical engineering student or mechanical or whichever course you are taking. I think this is a bit involving for maybe electrical engineering. Should be a little less. But anyway, the more differentiation you learn, the more it will reinforce you in understanding other concepts. But the good thing is, do you know what is happening? We will be shifting from the KICD syllabus, which mostly is examined by KNEC, to CBET curriculum, which will be examined by the training institutes or qualification awarding institutes, which means we will no longer have to examine as much mathematics as it's being examined in KNEC. That is good. It means very soon I'll be shifting from maths to more technical areas. So in the near future, I'll stop uploading mathematics videos, but I'll be uploading practical videos or videos to help you enforce yourself when it comes to actual practice in electrical engineering. I'll also be making videos on the change that is happening. So that is it. Let us meet in the next video. If I've not wasted your time in this video, certainly not in the next video.